algebra. We are continuing POFitty-Five with the third, Damien, the third form of an equation that you'll come across when dealing with parabolas, and that is everything. Y equals ax squared plus bx plus c. The first type of equation that we talked about yesterday didn't have the bx term. It was just ax squared plus c. The second type of equation didn't have the c term. It was just ax squared plus bx. This has got all of them. Okay. So our method for this, remember each one of these has kind of a certain method to it. Our method is factoring. Factoring, think PO51, think PO52. Two sets of parentheses, each one has an x, that whole situation there. So the good news is you've done this before, okay? And now we're going one step further. Who can factor mentally for me y equals x squared plus 9x plus 20? If you need a refresher on what that means, it means you're looking for two numbers that multiply to make 20, and those same two numbers. Hey, I don't want to hear your groan. I don't want to hear your groans. This is the easy one, right? It's the third one that you get to groan about. That's got the coefficient x squared. This one's the easy peasy. Okay, Bryn.
4 and 5.
4 times 5 equals 20, and 4 plus 5 equals 9. Okay? So what that means is that in our parentheses, they both get an x. One gets a positive 4, and one gets a positive 5. Now, in PO51, we stopped here, right? Because PO51 was just factoring. This is the factored form of x squared plus 9x plus 20. But now, in PO55, because we're solving for the x-intercepts, we want to set this expression equal to 0, like we did before, right? Y equals 0. And kind of like we did in our ax squared plus bx, we want to make each set of parentheses equal to 0. This is the second page of 55 bottom, before the one. Arlene.
I got the answer.
Yes, go ahead.
X equals -4 and x equals -5.
Okay. X equals -4 and x equals -5. Arlene, can you explain why those answers work here, why they make sense, why you decide on that?
Because -4 plus 4 equals 0, and so does -5 plus 5. And so when you multiply them together, you get 0.
Yeah, so if we plug in -4 into our first set of parentheses, we get 0 here, right? If we plug in -4 in our second set, we get positive 1. Does that matter? No, because our first set equals 0. And 0 times anything is going to give us
1.
0.
What?
Warning for you. Likewise, if we plug in -5 into our second set, -5 plus 5 equals 0. -5 plus 4 is -1, but that's okay. Because 0 from our second set times anything will equal 0. So just like in ax squared plus bx, you're looking for those two values for x, one that makes each set of parentheses equal to 0. That's it. Okay, that's the only extra step from the factoring you already know how to do. Okay, the next one, y equals x squared minus 3x minus 40. Two numbers that multiply to make -40. Same two numbers add to be -3.
5 and -8.
5 and -8. Looks good to me. Two sets of parentheses. One gets a positive 5, one gets a -8. And what are our two solutions for x? 8.
X equals 8 and x equals 5.
X equals 8 from this set. What value for x makes it equal 0? And x equals -5.
You just flip them around.
Kind of, essentially, yeah.
Every time.
Yeah. And again, just a reminder here, what do these two values represent? What did we just find? What's the whole point of solving for x for these parabolas? Elliot? The x-intercepts of the parabola. Okay, where it crosses the x-axis. We know how to find the vertex, we know how to find the y-intercept, axis symmetry, we can add the x-intercepts to our list of characteristics here. Okay. The last one, here's where I will accept groans. Because this one from PO52 is that 7-step process. The good news, though, at least for this one, is that we don't have to do step 1 because why? There is no greatest common factor to pull out. Okay? So we go straight to step 2, which is multiply that A and C term together, right? Which in this case is 6 times negative 10, which is negative 60.
Yep.
What's step 3? What's step 3? Kylie?
Figuring out what can be multiplied to negative 60.
Yeah, here's where we kind of start to build our 2 sets of parentheses. That negative 60 matters because we need 2 numbers that multiply to make negative 60, and those same 2 numbers add to be 11, that middle term. Good. Raise your hand when you got it. Don't say it. Raise your hand when you got it. What's the combo? 1, 2, no, 1. 1 half. 2, 3, 4, 5. 2 numbers that multiply to make negative 60 and add to make 11. Lisa, your hand was up first. It is possible, actually. It is possible. Anthony, your hand was up too. Did you want to share?
Negative 4 and 15.
Negative 4 and positive 15. Negative 4 and positive 15. Multiply to make negative 60 and add to make 11. Okay. Remember, there's only a certain number of ways this can work. There's an infinite number of ways to get 11 with addition, true. But remember, these numbers have to multiply to make 60. So you start writing down your factors of 60, albeit there are a lot of them. But it's got to be one of those combos. So then you start to go through that list and say, what can make me 11? And then you settle on 4 and 15 and choose the signs and everything else. Step 4, what are we setting up here? What are our 2 sets of parentheses? Ellen? Not x minus 4 and x plus 15. Remember, this is the one where we kind of have to bend the rules a little bit, but we fix it in step 5, so it's okay.
6x.
Yes, they each get a 6x, not just an x. They each get that a term. 6x minus 4 and 6x plus 15. And the reason why we do that is because if we didn't start them the same, then it would make a difference which one gets the negative 4 and which one gets the 15, which is just more opportunity to make a mistake. By starting them each with a 6x, that a term, we include that coefficient, and then it doesn't matter which one gets which constant. How do we fix this now? Since we did bend the rules, let's bend them back. Beckman?
Divide the first one by 2.
Right. We simplify. Okay? Divide 6 and negative 4 by 2. And then, Max?
Divide the others by 3.
And what about those numbers tells us that we're doing something right?
They all fit in.
They all fit in, yes. And 2 and 3 multiply to make 6, which was the original problem anyway, because we put an extra 6 in there, right? Now we're taking it out. So our parentheses become 3x minus 2 and 2x plus 5. We skip step 6, which is putting the GCF back in, which you don't have to do here because there is no GCF to put back in. Okay. So remember, this equals 0. I don't have room to write it, but this whole thing equals 0. So like we did in the first 2, we now have to figure out what value for x makes each set equal to 0. And this is where we can use our trick from yesterday. The opposite of the constants divided by the coefficient. What value for x makes 3x minus 2 equal to 0? Riley? Positive 2 over 3. Opposite of our constant divided by the coefficient. And what's our second answer? Ellen? Negative 5 over 2. X equals negative 5 over 2. Whew! This is big kid math right here now. Big kid math. Yeah. Questions on it? The only new thing here is this final step of solving for x. You've done the factoring before. And really, if you kind of just think back to what we did yesterday with ax squared plus bx, that solving for x part isn't any different either. Okay, but you are looking for two answers. Okay, and there you go. Questions? Comments, concerns, complaints, comments, congratulations, criticism. Yes. Spirit of Christmas. Thank you. Yes.
I have a complaint.
Yeah.
I don't like this.
I'm sorry. Would it help if I told you it gets worse?
No.
It gets
Then I won't say that.
Yes.
funny.
Just wait till PO-59.
But you are.
I think I'm just gonna stay in this class.
Okay. Your homework for what? Oh. Your homework for.
You know you
Ooh, that's a lot.
You know you like homework.
That is. Let's see. Do I want to assign everything?
I think it's not.
The spirit of Christmas. Huh?
Yeah, just the middle row.
Let's see. Okay. So I want you to do the second row because this is going back to, it's a review of ax squared plus c. So do the row that you didn't do yesterday. Then do this row. Oh, keep my star. Look at that. Same time. Do that fourth row also, going back to ax squared plus bx. And then,
Why? Do which row?
so the top row on the second page. So the second and fourth row, really, if you look at them all.
Yeah, I think that's good.
And then 3 of these 6. You can pick 3 of the 6. 3 of the 6.
That's bogus.
Okay. Now, immediately, a couple of these probably jump out at you as being, hey, that's not what I remember it looking like on the practice. Remember, in math, if something doesn't look the way that you want it to, make it look the way that you want it to. What we do here to this x times x minus 13 equals 30 to put it into ax squared plus bx plus 4. Aiden says distribute. Right? That looks more familiar. And then move that 30 over, and you've got your ax squared plus bx plus c. How about down here at the bottom? 4x times 4 or times x plus 4 plus 15. Distribute again, right? Right? This looks more familiar. Ax squared plus bx plus c. Right? There are a couple of them where they're not in center form, they don't equal 0. This type of equation has to equal 0 before you can factor it, like we saw in PO-51 and PO-52. So this 20 has got to move over using opposite operations. Here, this 22x needs to move over using opposite operations. Okay? Yes?
On the first page, second row, first one.
First page, second row, first one. First page, second row, first one. Yes, sir. What is your comment?
You have to square root a negative.
So yeah, so this one is set up to where to solve for x, you root both sides. And we've talked about this before. The problem we run into, Damien, is that we take the square of a negative number. We've talked about this though. Who remembers, Rowan brought it up. It was brilliant. My boss was here to observe. It was great, great tangent.
X equals 3, but with a J.
Not a J, an
I.
I, right? X equals 3i. And what does that little I stand for? Imaginary. What this says, this parabola actually doesn't cross the x-axis, but if it did, it would cross at 3. Yeah. If you put it, you could write it like this too, I suppose. That looks more like an I. That's probably like the Danielian I. That's your taught to write it, but most people, But yeah, so if this comes up with a math test, which will take next week, it probably will for some of you. The root of a negative number, it's what you would think would be 3, but then with an I, it's imaginary, yeah.
Would that still be like positive or negative?
Yes, I should say that.
Okay.
Right. Yep. And also though, in context, Liesl brought up a no solution situation before. This would be no solution since it doesn't cross the x-axis. Either answer would be correct. Okay. But don't just put 3. 3 is not correct. This problem does not cross the x-axis at 3. Okay. Thank you, Aiden. Other questions? Elliot.
On the third one on the second row, can you divide both of them by 7 to start?
Yes, you would. There's no constant to move. It's all already over there. So yes, you just jump right into dividing by 7. Anything else?
Can you like mimic the?
No.
You finish the middle one on the second page.
Middle one, second page. This 30x squared equals 72x.
X.
Oh, this one?
Yeah.
Well, where we left off was right here.
Yeah.
Okay.
Wait.
We would need to move our 30 over so that it equals 0. So the equation that you're factoring is x squared minus 13x equals negative 30. Okay.
Equal sign goes after.
Or sorry, my bad. My goodness. Whoopsie doo. That's just fun. Makes that great. Anything else? Okay. Thank you. You've got the homework. You got 9 of them to do. That is how you math.
Don't forget to
Don't subscribe.